Hey guys, we are graphing some absolute value equations today, okay? So when we graph these, we like to think of what we call our parent graph, okay? So if you were just being asked to graph y equals the absolute value of x, this is what your graph would look like, okay? But we aren't being asked to graph that. We are being asked to graph something that looks like this, right? We've got that plus 6 inside of there, okay? So this is going to be the same graph. It's going to be the V. It's just going to be shifted a little bit. So how do we know how it's going to differ from this graph? Well, this is our key. This tells us, okay? First of all, if there is a number out front, this one obviously, well, it's a 1. It doesn't have a different number than that outside here. If you want to see an example like that, I will link one in the corner. But really quickly, if there's a number out there, if it's positive, your V opens up. If it's negative, your V opens down, okay? And also, if whether it's a fraction or a number, a fraction's a number, a counting number, will decide if it stretches your graph or compresses it, okay? Kind of like this. You can see the green has a 4 out front and it's stretched. The red has a fraction out front and it is compressed, okay? But that doesn't apply to this current example, but I do think it's important to mention, okay? Now, we also don't have a K on the back. We could think of it as +0 if we really wanted to, if that helps you out, okay? So these two numbers here tell me how my graph shifts to the right or left and up or down, okay? So this +6 here tells me left or right shift, and you actually do the opposite of the sign. So when you see +6, you might think right 6, but we do opposite of the sign, so we're actually going to go to the left 6, okay? And then we've got that +0, you could think of it, which just means it's not going to go up or down at all from where the parent graph was, okay? So my parent graph, its vertex is at 0, 0, right? Well, this one, I'm going to move to the left 6. 1, 2, 3, 4, 5, 6. So that is where my new vertex is, okay? Now, some teachers at this point, they might just want to know that you know where the new vertex is and you know it opens up and you might be good. But if they want you to show a few more points on the graph, there's a couple ways you can figure that out. We're going to plug in to figure out, okay? Plug in some points. So let's go ahead and figure out where it crosses the y-axis, okay? Because it's going to go like this. Let's figure out where it crosses the y-axis. So to do that, I'm going to plug in 0 for x, okay? So I'm going to have y equals the absolute value of 0 plus 6. And I don't need to write that +0 there, right? So then I've got y equals the absolute value of 0 plus 6 is 6. If you need an absolute value review, I'll link one in the corner. But this is just asking how far is 6 from 0? What's that distance? And it's just 6, right? So y equals 6. So when I plugged in 0 for x, I got 6 for y, okay? So that point is right here, okay? Now we could plug in another point on this side if we wanted to, but I know that when we have an absolute value graph, it's the same on both sides, okay? So meaning from this point, we can figure out how far that point is away and do it on the other side, okay? So it was 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it's going to go off my graph, but that's okay. 1, 2, 3, 4, 5, 6, about there. 1, 2, 3, 4, 5, 6. So approximately, we're off the graph, but it's approximately there, right? Now, if you don't remember that, or if you're like, oh, that's kind of confusing, you can always just plug in a point and get one on the other side, okay? So, and pretend like that's lined up. Oh, it should have been a little higher, like about there, okay? So when we graph these, they are straight lines that make a V and should look a little something like that. Okay, hope this made sense. If you need some more absolute value videos, I will link a playlist in the corner for you. Thanks, bye.